Well, once again, I want to welcome you guys back. A little Easter break has been past us, and I wanted to tell you a little bit about what's been going on with our chapter here. We're in the chapter that deals with acids and bases. You've covered a little bit of it already. I have a little demonstration that I want to show you here that relates to a couple of the concepts that are in this portion of the chapter. So I'm actually starting on page 656 in your text, and I'm going to cover about 4 pages up to page 660. And if you're able to follow along with those pages, you'll do okay. In those pages, there are some calculations, so I'm going to list some of those as questions that I want you to do in your notebook. But at least to get a sense of how the values for acid-base concentrations change, what I'm going to do is this brief demonstration. Across the table here, and let me turn this so you get a chance to see a little bit better what I have. I have 1/10 molar hydrochloric acid, 1/100th molar of sodium hydroxide, and I have some distilled water. I've transferred solutions out of these to the beakers. Here's the water, here's the acid, here's the base, HCl and NaOH. What I've done before showing you this video and taping it, you're familiar with the 96 well plates. Well, I've prepared a 96 well plate where I've done a whole series of dilutions, and I can tilt this here and nothing really pours out because of the surface tension of the water. But I've taken solutions that gradually get more dilute as I go from the far right or the far left and I go in towards the middle. Now, to give you an idea what the well plate is like, I made a little diagram here, very similar to one we saw before. And let me hold it up so you can see a little close-up of it. On the far left, I have put into the very first well a 1/10 molar solution of hydrochloric acid. Over on the far right, I've put 1/100th molar sodium hydroxide, and I've diluted them in sequence, what we call the serial dilution. So I've gone from this well all the way over here to well 6, and then over here, starting with well 12, I've gone backwards and diluted this way to well 8. Well 7, I've left no acid or base whatsoever. So well 7 is a neutral condition. It's just distilled water. And how did I do that? Well, I filled every well 2 through 11 with 9 drops of distilled water. In this well, I put 10 drops of the acid. Over here, I put 10 drops of the base. So we have 12 spots in which the solutions are placed. And these 12 spots align very nicely with part of our pH scale. Our pH scale runs from a little bit less than 0 all the way over to 14, which would be off our diagram here. But it gives us a sense of how we can change the concentrations of the solutions in the wells to match what the pH would be up at the top. So starting with a 1/10 molar solution, and let me tilt this a little bit more for you. Starting with a 1/10 molar solution of HCl, and I'm down here now, that pH is an indication of the concentration of hydrogen ion. So my solution is 1 times 10 to the minus 1, which then translates, when you take the log of it, you use the negative exponent there, bring it up and put it in parentheses. So I have a -1, which when you combine the signs becomes a pH of 1. So my very first well is a pH of 1. It has the pure 1/10 molar acid in it. When I go to the far right, I can register and show the power of the hydroxide ion concentration. So in well 12, I have a negative log of the hydroxide ion concentration, which then equals a negative log of 1 times 10 to the minus 12. And that can be translated into the log value, a negative 12, or a pH of 12. So everything in this column here, and I have 4 sets of these, everything in this column is a pH of 12, everything in this column is a pH of 1, everything in the middle, which has no acid or base in it, is a pH of 7. And I did that pretty easily by the serial dilution. Once I filled the first well with my unadulterated solution, I took a drop out of this, transferred it to the next well, put the 9 drops back. Then I went to the second well, took a drop out, transferred it to well 3, put the rest back. Took a drop out of well 3, put it in well 4, put the rest back. I did that in sequence up to well 6, and then I stopped. I did it in reverse order over here with the sodium hydroxide, so that the sodium hydroxide started off in its 0.01 molar strength. 1 drop out of here, next drop, diluted it by 10, put the rest back. Took a drop out of here, transferred it to well 10, put the rest back, and each sequence here now dilutes it by a power of 10. And then column 7 is no dilution whatsoever of either acid or base. It's just pure water. Now, here's where the experiment gets kind of neat. We're going to take the solutions that we have in here, and we're going to add to them some acid-base indicators, which I have a little further over on the bench here. And we've lined them up for you. On the far left, I have bromphenol blue. The next solution I have is phenolphthalein. My next solution is universal indicator, and far right has methyl orange. Each beaker contains that dye or that indicator, and they have various colors to them. And I have a barrel pipette in each one, and the barrel pipette has the dye in it. What I want to do next is take the barrel pipette and put a single drop of the dye in the wells across row A. I'll use that for the bromphenol blue. I'll do it with phenolphthalein. I'll use row C. And then I'll finally do the last two on the next 2 rows, again putting a drop of each of the indicators into my solution. So I'm just going to start here, and then I'll turn the video off so that I can proceed and I don't have to waste too much of your time. So into the very first well, I'm going to place my bromphenol blue, 1 drop. And it suddenly turned yellow. So a drop is going into each of the wells. And I'll put this back, and I give it a little tap just to gently mix it. And here's my set of liquids, and let me put this up against a piece of white paper so you can see this better. My liquids change in their color and also in the intensity of their color. And right about in here, there's a drastic switch of the yellow into the blue or purple color. And that is happening at a pH of between 5 and 6. So I'm going to continue. I'm going to put the video in pause right now, and then I'm going to continue with my next batch of indicators, and I'll come back. All right, we've put all the indicators into the various wells going across, and as you can see, as I go from a strong acid to some basic side with the bromphenol blue, I am getting a change from yellow to kind of a dark purple or a purple color. The second row is the phenolphthalein. That starts off in the acid range as having no color whatsoever. It's colorless. But over here where the pH is in the basic range, it's changing to a kind of a magenta or pinkish color. My universal indicator, which is actually a blend of a whole bunch of dyes together, goes through a whole range of color. This is always very nice to see when you're doing titrations and reactions with acids and bases, because you can sometimes get a whole rainbow. And then the bottom one is my methyl orange. Starts off in the acid range in the reddish color, and eventually around pH of 5 starts to switch over to become an orange color. And the practical use of this is when I'm doing a titration or a blending of acids and bases, if I'm trying to figure out where's the switch off a strong acidic condition to a strong basic condition, what I frequently want to do is use a universal indicator with it, because that shows me the best set of color changes where I can get a sense of where my neutral is. So the color switch is right in this row with a pH of 7. Now, where is this located in your textbook? Well, I mentioned to you that we're starting with page 656. So if I look at page 656, in this little corner here down in the ranges of pH and pOH, I can see the columns of the concentration values. I can see the pH range here, and then I can see some common substances that are listed to the right. And this is really neat because a lot of the things that we work with and have around the home, they are in this column, and we can kind of say, oh, that has a pH of 3 or something of that nature. When you guys showed me the photos of the substances that you found around your home, that was interesting to me. There were a lot of bases that were picked, and that gives you a sense of, well, if I'm trying to clean things, get the grease off stuff, most of the time I want to use something that's got a pH in the range of 7 to 14. The last thing I want to show you on page 660 is a chart down towards the bottom that shows us all the different ranges of color for a whole series of acid-base indicators, not just one or two. They're very similar to what I've done here, so you can actually look at the chart, see the pH, and look at the vertical column and see the names of the indicators. So it gives you a sense of how we can use indicators to determine where pH switches over. Here's a column of pH of 7. So if I wanted something that was going to change color at the neutral condition, I would pick probably one of these 3 indicators that you see right in here. So as you read page 656 to 660, and you do some of the problems that are there, make sure you read a little bit of background in your text to supplement rather what I've mentioned here for you. Now, the final thing I want to mention to you, this is not a lesson, but with the COVID virus that we are experiencing right now, there's a number of people that are really doing some tremendous work in helping others, volunteers from our local area, our medical staff, nurses, and so on. I've also been following some of the emails on the Travis Manion Foundation website. And you might remember I talked about Travis Manion, the gentleman who is a former student from LaSalle College High School in Philadelphia. He, with his family, has become an inspiration to many people. So some of the people that are connected with his foundation have been volunteering, doing things like carrying people's food to their home or helping them with transportation, just being very generous with their work. So it's something for us to think about too, particularly here in Pittsburgh, because we're just a short distance away from some very important hospitals where some of this work is being done. So I'll end that with today, and enjoy the rest of your day. Take a look at the problems that I'll assign to you. Bye-bye.